Warahmatullahi wabarakatuh. My name is FARAH NAJWA binti ISMAIL. Okay, today I would like to do a question from subtopic Einstein photoelectric theory in quantum physics topic. Alright, the question is ultraviolet light with a frequency of 3 times 10 power of 15 Hz hit the metal surface and remove electron with a maximum kinetic energy of 6.1 electron volt. Calculate its work function in joule and electron volts. Okay, we list out the data, the frequency, the kinetic energy, maximum kinetic energy, and its work function. We have to find it. Okay, from the Einstein photoelectric equation, the equation is K. K is kinetic energy, H is a Planck constant, F is a frequency, minus work function. Okay, we have to find its work function, so HF minus K. Alright, so Planck constant is in the calculator, which is constant 0.6. So H, we put the details, the value of this frequency minus kinetic energy. Alright, this kinetic energy is in electron volts, but this HF is in joule. So we have to convert this electron volt into unit joule by times constant 23. You see? Electronic. Okay. So 6.1 times constant 23. So 9.77 times 10 power of negative 19 joule. So we have to clear out. So constant 0.6 times 3 power of 10, 15 minus 9.77 10 power of negative 19. So the answer is 1.01 times 10 power of negative 18 joule. So the question is asked us to answer is joule and electron volt. So from this answer, joule to electron volt, we have to divide by constant 23. Okay, so the answer is 6.30 electron volt. That's the answer. To the question number 2, the magnesium surface has a work function of 3.68 electron volt and photon with a wavelength of 210 nanometer on the surface and remove electron. Calculate the kinetic energy of the electron and the threshold frequency of the magnesium surface. Okay, we list out the information. Work function is 3.68 electron volt. Wavelength 210 nanometer. So we have to find the kinetic energy and the threshold frequency. Okay, from the previous equation, we use also same equation, which is K HF minus work function. Okay, if you remember, F also is equal to C over lambda. Speed of light divided by lambda wavelength. Okay, so we have to substitute this frequency into this equation because there is no frequency given in this question. So Hc over lambda minus work function. So H, we know that in a calculator constant 0.6. So speed of light, there is also constant, which is constant 28. Okay, constant 28. So Hc over 210 nanometer minus work function. Okay, this work function is in electron volt. So these are all in joule. So we have to convert this electron volt into joule unit by times constant 23. So 3.68 times constant 23. 5.90 times 10 power of negative 19 joule. So calculate all the details. Constant 0.6 times constant 28 minus 210 divide by 210 nanometer minus 5.90 10 power of negative 19. So 3.60 10 power of negative 19 joule. So in electron volt answer we have to times constant 23. So the answer is 2.24 electron volt. Okay, then we have to find the threshold frequency. For threshold frequency, the formula is threshold frequency work function divided by Planck constant. So we have this work function 5.90 times 10 power of negative 19 divided by Planck constant. So we got 5.90 10 power of negative 19 divided by constant 0.6. 8.90 times 10 power of 14 Hertz. Thank you.